the material would fail when its maximum shear stress is greater than its yielding stress. And sigma y denoting is the y denoting is the yielding. Okay, and what is this one? So this one usually is sigma y divided by 2. And sigma y is what we call the yielding strength. And in terms of the ductile material, if you do the material testing, then this will be the curve. And this material is going to break up. And this one here. And usually this is called the yielding limit. And yielding strength is defined by here. A little bit lower than, but most of the time the people, it's okay if you want to take the onset of the elasticity, then that's okay. This one is called the yielding strength. So that means it's to denote beyond which the plasticity is likely to occur. Okay, and this one, the sigma y, is usually one of the material properties, which means given a material, then the data book of that material should provide you this number here. Okay, so that is your choice of the material. Maximum, this one basically you can calculate it using the Moore circles. So usually to calculate tau maximum, usually step is this one. The step one is to calculate the principal stresses and say sigma 1, sigma 2, and sigma 3. Okay, so in this semester we have the section talk about how to calculate the principal stresses, either using Moore circles or using the formulas we have, assuming everyone have the access to the approach there. And then once we have the three things, then we can you can draw the Moore circles. For example, let me make one example here. Say, for example, if sigma 1 is, so this is sigma, if sigma 1 is here, and sigma 2 is here, sigma 3 is here, and I don't know their sign, maybe positive, negative, or whatever. So based upon the three numbers, we can make up three circles. One circle is corresponding to this one, making the circle passing to the 2 points, and this will be serving as the diameter. The second circle using the sigma 2, 3 difference as a diameter. The third one using sigma 1, 3 as a diameter. So who can tell me what is the for this example, what is the maximum shear stress?
For you said the largest circle.
Yes. So that means here. Okay. So that is a way to calculate this one. You're always looking for the radius of the largest Moore circle. And by all means, as long as you can draw the Moore circles for your distribution of the status, then go to here. Okay. And this is the concept. And then for two, so this step is okay for the step 2. The 2 step is valid for 3-dimensional general status of the stress. It doesn't matter that is a 2-dimensional or 3-dimensional, then that is working. And in particular here we put the 2D plane stress problems. And that is most of the time we are interested. And for the plane stress problem, that means if you remember the one component will be 0. So for 2D, basically that in terms of the writing, we have a sigma x, sigma y, and that is the tau xy. So that's what we mean the 2D. And that means in terms of the 3D drawing, this case is similar to this. It's basically identical to this. Okay, and then there's a strain stress here, and then the strain stress here. So that means in this plane, nothing there. Okay, so that's what we call the 2D or plane stress. And for this one, basically, if you look for the Moore circle, then the principal stresses one will be 0, and one will be sigma 1, one will be sigma 2. Because sigma 1, sigma 2 basically corresponding to the principal stresses of this one. The third one, because the sigma z here is 0, so that corresponding the principal stresses will be 0 here. Okay, so basically from here you can see this is a simplified conditions of this one. Okay, we put 1, 0. So here we can make a few kind of deductions here. So we make a few conditions. So we talk about the comparison of the sigma 1, 2 with 0, and we can make up the complete the scenarios for covering all the possible situations for those numbers here. So for example, the first case is the sigma 1 and sigma 2 are both positive, and then ordered in this way. So from this case, then you can see, let me do the scratch here. Okay, this scratch is, let me do that here. So for this case, the sigma 1 is here, sigma 2 is here, and then 0 is here. Okay, so that means for here you can clearly see the biggest circle is this one, right? What is the maximum? The maximum basically is sigma 1 divided by 2, right? Okay, so that means here, for example, here the maximum will be sigma 1 and the minimum will be 0. So that means the criteria, the criteria is sigma maximum, say at the onset, this sigma 1. And this one, maximum, basically is equal to sigma maximum minus sigma minimum divided by 2 is greater than or equal to 2 sigma y here. Okay, so basically the criteria is this one. So for this case, you can see our maximum is sigma 1, minimum is 0 divided by 2 must greater than or equal to sigma y divided by 2. And to simplify, this one basically is sigma 1 greater than sigma y. Under these situations, the failure would occur. So we can do the curving. So this will be the single plot, and if you like to plot it, you can plot it in a good way, because this one we have in total 6 conditions. 1, 2, 3, 4, 5, 6, and each condition will be imposed on the single plot here. So let me say this is the maximum and this is the minimum. Okay, in our textbook, and I think if you go to our textbook, chapter 7 is about the Moore circle, and there's one single section called the failure criteria. Go to there, you should see the figure here, the figure here. In our textbook, they use sigma 1 and sigma 2 to denote the maximum or minimum, just for notation here. So for the first conditions, that is in this project here. So this is the sigma y. So for the condition that happen in sigma 1 greater than sigma 2, so that means in this project here. So if I would draw the 45 degrees, so this is the 45 degrees, then this is the area for condition 1. for condition 1, then I want to draw the boundaries and margin beyond which the failure would occur. That is this one. As long as the maximum is beyond this red line, then failure would occur. So that means if you have any material be loaded up and you calculate the maximum principal stress, if that value of the maximum principal stress is fall outside of this boundary, then that would occur, the failure would occur. If that maximum value fall inside this boundary, then that would be safe. Okay? So here I will highlight this one is a safe region. Okay, the safe region, any status of the stress point falling into that one. Okay, then the second condition is here.